Lesson 9.5, Video 3. Solving rational equations with more than one fraction on one side. Now we're going to go through some steps here that's going to involve a new method of solving these. It involves getting a common denominator, but the new step is that we will cancel the denominators out once we have common denominators and focus just on the numerators. And that's good news, because whenever we can get rid of fractions, the less likely we are to make mistakes. So the first thing we have to do here is decide what is the common denominator. And I have a 3, a 2, and a 6. So the common denominator between those three numbers, the least common multiple, would be 6. The variables are easier. You would take the variable with the highest power. So this is our common denominator. So the first fraction, in order for it to have a denominator of 6n squared, needs to be multiplied by 2, and it needs one more n. So I multiply top and bottom by 2n to keep it proportional. The second fraction has 2n squared, so it needs to be multiplied by just 3, because it already has the n squared. And the last one also needs to be multiplied by just 3. What that gives us now is 2n times 1 is 2n, plus 3 times 1 is 3, equals 9. Now all of these would have a common denominator. So I have 6n squared, 6n squared, 6n squared, and the beautiful part about this is I can now just ignore them and just focus on the numerators, which allows me to solve for n. So we have to ask ourselves, is 3 our answer? Well, it solved to be 3, but if I go back to the original problem and I say, are there any values that would cause the denominators to be 0? And there is. 0 is the excluded value. So I cannot get 0 for an answer, and I didn't, so this one works. Next one, we have a subtraction problem, which we want to remember. We should always change to adding a negative. Our common denominator in this one, well, 6 is the only number present in all three denominators, and again I take the highest power. So this would be considered our least common multiple of those three terms, so in other words our common denominator. So our first one needs two more n's, so n squared. Our second one needs a 6, and our last one needs a 6. So if I multiply these together, I get n squared. I have 6 times negative 1, so minus 6. Now I have a binomial up here on the numerator of the third fraction, so I have to remember to distribute. And now I have an equation without fractions. Again, I can do this once I have common denominators, and that process just accomplished that. Noticing that I have a squared term, I have to bring everything to the left side and set equal to 0. So now I have n squared minus 6n minus 6 equals negative 6. I add 6 to both sides. Now we have n squared minus 6n equals 0. Now, it not being a trinomial and just a binomial allows me to look at it and say, is the difference of two squares? It is not. Do they have anything in common? They do. Oops. Sorry. So, since they have something in common, which is an n, I'll factor that n out. And I'm left with n minus 6. So this is the zero product property at work. What would cause this binomial to become 0? A positive 6 would. What would cause this variable to become 0? Plugging in a 0 would. So I have two solutions, 0 and 6. I go back to my original problem and I say, are there any numbers that would cause the denominators to be 0? And there is. It cannot be 0. Noticing that my solutions have a 0 in it, I cannot accept 0 as one of the solutions, because if I were to plug it in, it would not work. I would get a denominator of 0. So 6 is my only true solution. And this ends Lesson 9.5, Video 3.